If you're looking for a solution reporting the health, the network traffic, and the profiling of your application without any instrumentation, then this episode is for you. Welcome back to the Is It Observable channel. Today's episode is going to be part of the Kubernetes series where we covered lots of various topics. How to measure the cloud costs, what is Ebpf, what is Linkerd, what is Cilium and Humble, what is the Gateway API, and recently, what is Ambient Mesh. Today's episode will be focused on a CNCF project that provides observability in your cluster, reporting the health of your nodes, the pods. It also provides information about your application traffic and even the profiling of your code. And I'm referring to Pïxies. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you're going to learn out of this episode. We'll start with an introduction, reminding how to observe your Kubernetes cluster and reminding the challenges of a technology like Ebpf. We'll look at Pïxies, architecture and components. We'll look at the default scripts provided by Pïxies. We will look at the plugins provided by Pixie, and as usual, we'll jump into a tutorial. And today, we're going to try to export the Pïxies data into Dynatrace. Observing a Kubernetes cluster requires having the right signals to understand precisely what is happening within our cluster. But in fact, this topic could be understood differently depending on who is looking at the data. To simplify, I would say there is, in one hand, the platform owner that is in charge of provisioning the cluster, upgrades, providing standardized security processes, networking. Well, in fact, he's making sure that the project teams are able to work and deploy in the cluster. Then you have the other persona, which is the project team. They want to make sure that their application is healthy, working fine, and have the right level of details to troubleshoot potential issues on their application. So observing a Kubernetes cluster will clearly require to get the full signals of observability to answer to all the need of all the team members. As you can understand, the level of observability is a bit different depending on the persona. So platform owners are usually comfortable with the metrics, events, and a bit of logs. Traces could be useful, but it's not really mandatory in this particular case. One thing that could be very useful, especially if you're designing network routes or network policies in your cluster, is to have a network flow or a service graph of all the workload running in the cluster. The project team, on the other hand, they want to get enough details to be able to troubleshoot when it's required. So they usually need metrics, events, traces, logs, profiling. To be able to collect all those signals, we can do it in various ways, like explained in this channel, using Prometheus, of course, Prometheus exporters, open telemetry, vendor solutions, or relying on a powerful technology that will help us to get observability data and security information, and I'm referring to Ebpf. Like explained in the episode explaining what is Ebpf, Ebpf is a technology allowing us to create programs sitting in the kernel space and that will be triggered on specific syscalls of the kernel. The purpose of those programs is to collect or modify the data after an event has been triggered. For example, if I want to report the number of bytes splitting by folders, I could easily be done by creating an Ebpf program that will be triggered after a VFS write event. So that will be after writing data in a file. That program could collect telemetry information and then store it into a storage. And in the case of Ebpf, it's going to be a BPF map. The Ebpf programs comes in two parts. There is the probe sitting in the kernel, the Ebpf program collecting and writing data in the storage, so the BPF map. Then the second program will be sitting in the user space and will be in charge of reading the data collected in the Ebpf map and will store it into an observability solution of our choice. To be able to load an Ebpf program, you can clearly imagine that you need the right privileges to be able to load it into the kernel. I would say that this is the most challenging part when using this technology. The other challenge of using Ebpf is the fact that you need a recent version of your Unix kernel. In fact, it's going to be above version 4.14. This is usually a false problem because most of our workload runs in the cloud, and we usually get from our cloud provider the latest versions of the kernel. So it means that Ebpf is an awesome technology that could provide a lot of great features for security and observability, but I would say it is even more powerful when it runs in Kubernetes. If I deploy an Ebpf probes in Kubernetes, what could I technically collect? Well, anything related to a syscalls running in the node of our cluster. So it means anything about network traffic, processes, which means container, memory, CPU usage, well, almost everything. Lots of solutions providing Ebpf support mention that they are able to provide tracing. Usually when you think about tracing, you imagine distributed tracing. Well, in the Ebpf world, the term tracing means the network tracing, collect details about the traffic flow that goes within the network. So I would rather phrase it into network tracing more than tracing in general. Currently on the market, there are several solutions using Ebpf to provide observability data from our cluster. So ground cover, oligos that we recently presented in this channel, Parka, awesome solution to do profiling, and of course, Pixie. Pixie is an observability solution for Kubernetes based on Ebpf. One important aspect is that Pixie has a data retention of 24 hours. What? Which means you will need to use Pixie plugins to send the data to a third-party solutions to have a longer retention. You can ask yourself, why is it limited to 24 hours? Well, in reality, Pixie has been designed to provide features to debug, drill down into a potential problems within our Kubernetes cluster. You will see that Pixie provides lots of great features, so Pixie scripts, that will be designed to debug or to trace and potential problems within our cluster. Before looking at what Pixie is able to achieve, let's have a look at the architecture. Pixie has a UI named Pixie Cloud, designed to manage users, manage the authentications, the data. This component could be hosted or you can self-host this component. So Pixie Cloud could be either in your same cluster as your applications or running on a remote cluster. Then to collect data in the cluster, Pixie is made of several components. So first you have the Vizier operator that will be used to make sure that all the Pixie components are running and are up to date. Then you have Vizier, which is responsible of collecting and processing the data from the cluster. Technically, Vizier is made of several components. So first you have an agent, so named PEM. PEM stands for Pixie Edge Modules that will be deployed on each node with the help of a daemon set. The agent deploy Ebpf programs to collect data from our cluster. Then you have a collector, a sort of collector named Kelvin. Kelvin will receive data from the PEM agent and will aggregate all the node at the node level and complete the script execution by processing the data. We have Vizier metadata, a very important component because it will add the right Kubernetes context to the data collected. We have a Cray broker that handles the script's execution. It distributes the scripts to the different PEM components deployed in our cluster. Last, we have the cloud connector that connects the Pixie cloud to the Vizier. So at the end, it means that one Pixie cloud instance can handle several Vizier instances. So one Vizier per cluster, which means one Pixie cloud can manage several clusters. What is interesting is that Pixie provides several ways of accessing the data. Of course, traditional from the UI, but also there is a CLI. So similar to the project like Istio, Linkerd, Pixie provide a CLI that will help us to deploy Vizier in a new cluster, but it will also provide lots of various commands to fetch statistics from the Pixie, a bit similar to kubectl, for example. Pixie also have an API allowing us to access to Pixie's data with the help of the API. It means that we can create scripts interacting with Pixie API to build integration with a third-party solution. At the moment, Pixie provides a Python and Go client for their API. To collect the various data from our cluster, Pixie will execute Ebpf program through the PEM agents. The Ebpf programs collects various types of data. Of course, this can be extended by running new programs using Pixie program language called PXL. By default, Pixie will capture the traffic generated by our applications and produce tracing. Well, I was meaning network tracing. Pixie currently supports a limited list of protocols. So, of course, the HTTP, HTTP2, DNS, NAT, MySQL, PostgreSQL, Cassandra, Redis, Kafka, and INQP. Pixie is able to decrypt encrypted traffic when it's encrypted with OpenSSL or with GoTLS. It will also, of course, in the case of Kubernetes, it will capture resource metrics from our cluster, so we will understand the health of the cluster by looking at the nodes, the namespace, and of course, the pod. We will also get network metrics, JVM metrics, and application CPU profile. Pixie provides out-of-the-box continuous profiling on Go, REST, C, and C++. All the logic behind Pixie is related to scripts. Yes, scripts that would be executed to collect data from our cluster. But this logic of script will also be available within the UI. So the scripts will be responsible to get the data stored in data frame and process the data and create new fields out of the raw data and also create a visualization. So Pixie doesn't have a dashboard features that you can find in many products like Grafana, for example, or Dynatrace. The UI will be defined through the scripts. So Pixie even provides Scratchpad. So it's a feature that helps us to design PXL scripts, to run them, to test them, to debug them, to adapt them to customize the visualizations of the data that we have collected. At the end, the idea is to build your own custom plugins with the help of those scripts. When building a script, technically a screen, in fact, you define what type of data I want to collect and process through the PXL scripts language, and how I would like to visualize it using the Viz specifications. Pixies provide lots of data source, but few elements is missing to answer the requirements of our team. Log is currently missing. It seems that it is in a beta version for Go programs. If log is missing, it also means that events is also missing. So observing a Kubernetes cluster without having events, it's kind of painful. Next, Pixie is not generating any distributed trace, but you can still produce those traces from the data stored in Pixies and send it to your observability solutions. I would say that lots of features provided at Pixie are just amazing, such as profiling, the network tracing. It is just that few things are currently missing to fully able to diagnose an issue. Like expected from a Kubernetes observability solution, Pixie provides first a cluster overview. The cluster overview shows us the HTTP service map. This service map shows us the traffic that is currently going through the services and the pod. From the screens or scripts, we can also see the health of the nodes by mainly focus on the CPU usage. We can also see the various namespace showing us the number of pods, the number of services, and so on. We can see all the various community services, and for each services, we're getting the P99 latency, the throughput, the error rates, the inbound and outbound connections. And last, the pods showing us the CPU usage, the disk read, the disk write, and so on. If we click on the screens on a node or a pod or a namespace, it will open a new script with the right filters. So it means that I can do a deep dive on how a particular node or namespace or pod or services is behaving. If clicking on the namespace, it will run the px namespace scripts that provides the similar information provided by the cluster overview, except that we don't get the node health. So we get the service list, the pod list, and the HTTP traffic. If clicking on a given node, we will run the px node scripts that will show us the pod lists, graphs with the CPU usage, the byte read, the byte write, the network traffic, and the CPU flame graph on what is currently generating CPU time on the node. If clicking on a given service, it will run px services that will show us the HTTP request, the HTTP error, the HTTP latency, the pod list, the inbound HTTP traffic, and the slowest inbound request. If clicking on a pod, you will run the px pod scripts that will show us several graphs with the HTTP request, the HTTP error, the HTTP latency, the CPU usage, the container lists, the process lists, and also the pod performance plane graph. This is what we're gonna get if you are browsing from a cluster perspective. But Pixie also provides more information with the help of different scripts. There's the px HTTP data that show us the HTTP traffic, the source, the destination, the request parameter, the request body, the request header, and so on and so forth. So at the end, we can drill down to any HTTP request that has been triggered in the cluster. Pïxies has various HTTP scripts, so the px HTTP data filter to filter only on specific requests or response body and so on. The HTTP post request that will focus on HTTP request with post methods, so perfect for gRPC. HTTP request status, and so on. Otherwise, we also get dedicated scripts for DNS traffic from our cluster. This is possible by running the scripts DNS data, DNS flow graph, DNS query summary, and so on. Similar to HTTP, Pixie has dedicated scripts that will drill down on specific traffic of given protocols, so Cassandra queries, Kafka messages, MySQL queries, PostgreSQL queries, and so on. So at the end, we get the right level of details if you're using those technologies. And I also mentioned that Pixie is able to show us the network traffic that is possible with the usage of a couple of scripts like the px netflow graph that will show us the traffic on a specific namespace, the px network status that provides the overall network traffic of this cluster, the px TCP drops focused on, of course, TCP drops, the px TCP retransmits for the retransmits. One interesting point is that we can trigger Ebpf trace. If you see a potential problems, we can trigger those scripts. So Pixie has predefined list of Ebpf trace like the DC snoop, XX snoop focused on the behavior of system calls, the XX snoops on system events, nap time showing us application having sleeps on the socket.io requests, Ebpf trace OM-kill showing us details related to system OM-kill events. All the Ebpf trace scripts won't be running by default in our cluster. We need to select the scripts and run it to collect the live trace points that we're looking for to debug. But what would happen if we have 100 users triggering the execution of different Ebpf trace at the same time? Well, I'm wondering, I'm pretty sure that we can have some surprising impact, but if you have experienced this situation, please drop a comment to this video to share your experience. Pixie provides a plugin system allowing us to send the data to a long-term storage solution. As of now, Pixie provides two default plugins, so the New Relic one and the Open Telemetry plugin. The New Relic plugin is collecting various type of data and sending it to the Open Telemetry ingest endpoint of New Relic. This is quite interesting because at the end you get the metrics collected by Pïxies, but also it generates spans out of the network traffics. This is quite exciting. The OTel plugin, on the other way, is much more lighter and will send few information. So the connection stats metrics, the network stats metrics, and resource summary metrics to show us what's going on in the cluster. Of course, you can build your own plugin that you will need to define two files, two YAML files. So plugin YAML file describing the plugin, the logo, the name, the descriptions, and the retention YAML files that will have predefined PXL scripts to be executed every X sec. Because Pixie has a natural support for OpenTelemetry and most of the Observability solutions supports OpenTelemetry, it makes more sense from my perspective to upgrade the hotel plugin rather than building a new plugin. For example, I would say we could copy the PXL script used by New Relic plugin to use it in the hotel plugin. The other integration that Pixie provides is a Grafana data source that will allow us to define dashboards from Grafana. The data will be extracted from Grafana using the PXL query language. So here is an example. In this tutorial, we will use Pixie Cloud hosted by Pixie. We will deploy Pixie Vizier in our cluster, and we will look at the various dashboard screens provided by Pixie, and we'll try to extend the OpenTelemetry integration by using the scripts provided by the New Relic integration into the OpenTelemetry integration. The purpose of this tutorial will be to send the data collected by Pixie to Dynatrace. So for this tutorial, we will need a couple of things: a Kubernetes cluster, of course, the cert manager, and the hotel operator, because we will use the hotel demo application, and all the telemetry data produced by hotel demo will be sent to a collector. We will deploy the Pixie Vizier, and we will adjust the OpenTelemetry plugin by adding new PXL scripts.
So, like every tutorial that we deliver at Is It Observable, we are looking at the GitHub repository related to the episode about Pixie. So, similar to the other explained previously a few seconds ago, you need a cluster. So in my case, I'm using JKE, but there is no specific requirements of using JKE. You can use whatever flavors of Kubernetes that you want. Like I said, also the objective is to send the data to Dynatrace. So if you have a Dynatrace tenant, that's great. If you don't, then you click on the link Dynatrace trial and put your email address, and you will get a fresh new tenant. The other thing that you need for when you get your Dynatrace tenant is to have, like explained in a lot of the first tutorials, is to get an access token. So if you click on the left menu on the bottom left, you have access tokens here, and you would need to generate a new token. And similar to the other tutorials, you will give a name to that, and you will have to type ingest. And because we're going to receive data from the hotel demo application and also from Pixie, we're not going to ingest events. It's going to be mainly be logs, metrics, and traces. Technically, logs, I would say it's not required, because at the end, Pixie and the hotel demo will mainly send metrics and traces. So both those two scopes will be more than enough for this tutorial. So click on generate token on the bottom. And of course, this token will be displayed once. So please save it, because then you will need it for the script. The other requirement for the script is the Dynatrace tenant URL. So if you, in the top of the browser, there is your URL displayed here. So take everything, HTTPS, the name of your tenant, and then until.com, and don't take this last slash. That will be required, and you will save it into the DT tenant URL variable, and the token will be saved in the data ingest token. Once you have that, of course, you will clone the repo, and you will run the deployment script. So what you will get once you have executed this script, a couple of things. So first, if you look at the namespaces, at the moment, we have not deployed yet the Vizier in that cluster. So just the basic stuff. So I have a couple of things related to JKE here, but I have an ingress to expose the hotel demo application. I have the hotel demo, of course, namespace. And then we have two technical namespace, which is the Open Telemetry Operator System and the Cert Manager. So those two namespaces, we're going to not touch them, but they are required because we use the hotel demo operator. Not hotel demo, the Open Telemetry Operator. Last, we have a collector sitting in the default namespace. So if you pay attention, if you do kubectl, you will see that two collectors are running, and here this is the I would say the endpoint that will be used once we touch the plugin of Pixie to ask Pixie to send the data to this endpoint. And this endpoint, of course, is the collector. It will send back the data to Dynatrace. So the collector is already configured. We're not going to touch base on this. It's available on this repo. But just to let you know, there is a collector with a pipeline that is already configured that is sending the data to Dynatrace. On the hotel demo side, each of those workload has two containers in each of those pods because we are adding the a sidecar collector just to collect locally the telemetry data. I could have removed that and send it directly to this collector, but in this case, I did that way. The other requirements that is needed is to get a Pixie Cloud account. I'm not covering the way you deploy Pixie Cloud in your own cluster. I wanted to make it more simple to just cover on the feature of Pïxies. But of course, if you want to go on that journey, follow the Pïxies documentation. Once we click on the link, you will get the login page. If you don't have a Pixie account, no worries. You could basically sign up. In my case, this is what I'm going to do. I'm going to sign up with my Google account. Here it is. And that will bring me a new Pixie Cloud instance that I would be able to use for this particular demonstration. So here, this is the command to get the Pixie. So once you have installed your Pixie CLI, you would have the Pixie available. So a couple of things. And to be able to deploy Vizier, we're going to use the Pixie CLI. That will make our life much more easier. So to be able to authenticate Pixie CLIs to Pixie Cloud, because at the end, this is what we want to do, we will have to run the following command. So Pixie auth login. And that will bring you to this this page here. So I'm going to copy it. It will basically display a token, which here it is. And this token will need to be pasted in our CLI. So that will be a way of connecting this CLI to our Pixie instances. Once this is done, then we could simply type the command Pixie, so Pixie deploy, and that will deploy everything. Here it is. As you can see that it's going through the deployment, and it's just asking if it's the right cluster because it's taking the kubeconfig information, and this is the true. And then it's going to add all the components of Vizier. So now everything has been deployed. So now what we can do is to run kubectl and look at the namespace. So as you can see, a few things. So first, we have the Pixie operator namespace. Pixie requires OLM, so it's obviously here, like expected. And we have PL. So let's jump into. So here, as you can see, we have the on the PL, so the Vizier, I would say. So the operator will make sure that those components run properly, like explained. We have the daemon set for the PM. We have the deployment for the metadata. We have Kelvin has a deployment. We have the query broker as a deployment. Of course, we have this PL NATS is also attached to to the metadata, and we have the cloud connector. So those are the components that you should expect from your Pixie deployment in this Vizier, in this case, because we deployed Vizier in this cluster. So here, as you can see, we have a Vizier, we have Pixie with the live view as of now. So we can also change the latest timing. What is important, so here you can see that I can zoom in this cluster. So here we see obviously what happens on the HTTP service map. All the things that are happening. So you can see that we have Opel demo applications, we have the Kube system. So we have actually the entire HTTP traffic that goes into that cluster. We have the nodes here with the various usage, the various namespaces. So you get an actual view of everything with the various services, the latency, and so on. And then if I want to jump into a particular component or a node or a namespace or a service, I would be able to do that. And it will basically, you can see here, it's changing scripts, putting the right filter, and I will be able to see the actual what happens on this specific node, which pod is running, and a couple of graphs related to the behavior in this specific node. And I get, similar to I explained, the CPU flame graph for this particular node. Again, you can also from there jump into a specific workload. Let's say I want to click on the cart service. And so cart services is not doing HTTP requests, so that's why we don't have the HTTP latency. But I'm getting some CPU usage, the container lists. I can see the collector container, and a couple of informations. And of course, because it's not HTTP, you can see that we have this flame graph generated for this specific pod performance. But let's go back to the cluster itself. So if I click back to the cluster view, and let's pick now the namespace. So similar now, I'm going to want to specifically look at the hotel demo. So it will basically show me the service graph again with the various net traffic going on for the HTTP communications. I see the services here. So I have a couple of details and the pod list. So now let's say that we are interested to specifically look at the front end, which is the entry point. And here I see the request, the HTTP errors, the inbound traffic. And what I typically really like is the fact that I can see the actual request body of this specific requests. So this is really insightful. I can see here it's JZip, so I'm not seeing it, but here we can see that we have some response. This is stored as well. So you get pretty much of details if you want to understand what's going on. And of course, so that is useful when you need to drill down or something. So this is basically how you browse. So I can still here switch the script service to another service if I want it. But what is interesting is you can see here we have access to all the scripts. And for example, I want to look at specifically the post requests because it's gRPC. I can see all the post requests in this cluster from all the various components. So I can see here we see even the traffic for the OpenTelemetry collector. So you get everything. And what is interesting here is the scratchpad. Like explained here, if I want it, I can run my own scripts. So build my own scripts to collect or process or visualize specific information that is collected by Pixie. And the Viz specs will basically explain how it's like a CSS file, I would say, that will basically make the display. So what is interesting thing is I can still, for example, take one of those existing scripts. Let's say I want to look at the cluster, and I can see on the side here I have the actual Vizier. So which means I can still, instead of starting from scratch, I can start with an existing screen available and use those portions of the code to adjust and build my own, I don't know, my own visualizations if needed. So now that we looked at the various stuff, there is an icon on the left side called data retention. So here, it means that we have a 24 hours data retention, but if you want to extend it, you need to configure a plugin. So let's configure it. And as I said, there is 2 plugins available, OpenTelemetry and New Relic. So let's enable the OpenTelemetry. And here, so we don't need MTLS because here it's sitting in my cluster. So what I'm going to do is take the actual URL of the collector that we use. So I'm asking to send the data to the hotel D collector, sitting in default namespace, service cluster local. So here, this is done. So now I can save it. And now it's actually running. When you go to data retentions, you can see basically the scripts that are running. So you can see that there's 3 of them: connection stats, network stats, and resource summary. You can see the export status, which is interesting. If you have an issue, you can still debug. So here I can see the export status, and I can click on which cluster I'm referring to. And you can see at the beginning, I did type a wrong URL, and then now it's going smoother since I changed it. So you can understand what's going on, and if there is a problem, for example, here you can see that it's failed. It doesn't have the endpoint. So at least you get the right information. And then if I want, I can configure the script. So I can edit this and look at the scripts that is currently running to adjust it if needed. So now that we have this, what I did, I have in the repo, if you go here, I have a Pixie plugin repo, and I just simply, I didn't reinvent anything. I just took the various scripts that is currently running for the New Relic one, and I'm gonna copy them. So to do that, we're gonna be very simple. So I'm not gonna do everything for you. I'm gonna do 2 of them, and then I will do the rest offline, and we will look at the results back in Dynatrace. So to create a new script, it's very simple. You can create a script. So let's start with the HTTP metrics. We're going to pick which plugin we want. We can make a description if we want, and we can say all the clusters or one specific endpoint. So here is the default URL. And then here I'm going to remove this piece and copy the actual scripts that is in the HTTP metrics. Let me copy that and put it here. So now I have it, and I'm going to create it. So now you can see that HTTP metric is here, and it's going to run soon. So I can basically look at it. So once it's been executed, we'll have some data to figure out. If you can see here, it's already working. So we're already collecting things. So let's do the same thing for the HTTP spans. And then for the rest, I will add it manually, and I will show you the results that we will get. So HTTP spans, I can be shorter that time frame, but 10 seconds is good for this demo. And again, I'm taking the HTTP spans folder scripts, and I'm putting it here. So now I create it, and in a few seconds, once the script has been executed, I will have the details if this one is running or not. So let me add all the scripts. All right, so now all the scripts are running, or at least are running properly. So I had a few issues that I just resolved, so you should not experience the problem that I just had. So all the scripts are running, so let's see what we get in Dynatrace. So once the plugins has been deployed, we should see things in Dynatrace. So first, let's click on services on the left side. And services will bring me, so let me, last 30 minutes, that will be enough. Bring me to the actual services, things that are running here in this cluster. So we can see that we have the alert manager. So we have the Kelvin. So we can see that I don't have only the hotel demo application anymore. I have a couple of things about Kube systems. I have a couple of things about Vizier. So it brings me more things than I had initially by just with the traditional open telemetry demo applications. So for example, let's look at, let's say, I'm interested to see the one that are with the name of the workload. So those are the ones that are fully generated by this app. So if I pick one of these service here, it will bring me to the service screens, and I can see the various throughputs, and I can see all the endpoints, all the URLs that is generated by this hotel demo applications, and I have a lot of spans, so I can see API product and see what we are getting. So at the moment, the scripts could be improved to get more details, but what I can see here is that the HTTP header is here. I can see the response headers, and it will be also interesting to get maybe the HTTP response if I wanted to, for example, get more, get some rules or some things. But it's doing it automatically, which I think is pretty cool. So let's go back. The other thing that we should have is metrics. So if you click on metrics here, and we go to the bottom, you get a couple of details. So first, all the resource underscore, those are the one built by the resource metrics plugin. Then we have Redis, so you can see the Redis bytes, and we have the various metadata that are also filter. We also, if you go, so every metrics has the name, plugin name, the script name, and the details. So you can see now normally, so here network stats, that will be the network stats from the plugin, and then we have Kafka. So we could basically look at resource, for example, resource. Those are the information that we get from Pixie, and if I create a chart, I may have a different dimension available. And for example, I want to see the CPU usage of a specific deployment. And I can see that it's bringing me the actual CPU usage. So it's pretty interesting. At least you get a lot of various details. And because it's with the hotel plugin, it means that you can easily export it and get a longer data retentions.
That's it for today's episode related to Pixie. Pixie, I think, is an amazing solution to observe your Kubernetes cluster. The only limitation, like explained, it's the fact that it has a 24 hours data retention. So it's clearly been designed to debug, to drill down into your problems. So I think the cluster overview showing you the node, the pod, the services is amazing, especially showing you the network flow, the traffic going on in the cluster, and also being able to jump into the details of your Kafka messages or your SQL queries. I think it's quite powerful. The only thing that is missing from my end, I think, is the logs and events. I'm pretty sure that they may extend it, or maybe the priority is to send the logs to another storage and visualize it with another solution like Dynatrace or New Relic or others. I like the fact that you can also run Ebpf trace. Especially, it's really useful, for example, if you have an OM kill event, to understand precisely why you had that problem at that moment. But one thing which is important from my perspective is that the experience of Pixie will completely change from the moment you know how to write your Pixie script, so the PXL language, because with that knowledge, you can customize the data that you want to collect. You can create new screens. You can adjust the screens depending on with the information that you need for your team. So I think PXL scripts is clearly required to extend the capabilities of Pixie's. If you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. Bye.